Hi. Well, thank you all so much for coming out here. And because I love the sound of applause, just really quickly, for all the organizers for putting together this amazing event. So, buenos dias. I put this in front of every talk that I give. So if you've seen my talk and seen this shtick before, I apologize. But what I do is I kind of like turn my back to you and I look at the cat and I just kind of... And at first, I did this for myself. This was kind of like a calming exercise because I was nervous, there's all these people, I'm going to say something silly, and I just look at the cat and then like it would hypnotize me and I'd be like good to go. But eventually what I realized was that it was a litmus test for the audience. It helped me figure out, is the audience cool? Because if you're laughing, then like we're going to have a good time, but if you're silent, like I'm totally in trouble. But good news, you're a cool audience, so this is going to be a good talk. So as we were saying, my name is Myles. I'm a developer advocate at Google. I work on the Node.js platform on the technical steering committee and do work internally on products for Google Cloud Platform. So if you have questions about Node.js or about Google Cloud Platform or like just like life or music or whatever, just grab me afterwards. I love to talk. Dear Diary, today we broke NPM. I did some research. I think that's a vodka factory, but I'm not 100%. So it turns out that an API that we had deprecated in 2010 was never actually deprecated. We just put a comment in and then never did anything. So there was a warning that would come up when you used it. It was specifically for using fs open with a string because you're supposed to give it a file descriptor. But the change landed to remove it, and it broke NPM on master. And I think most people who have Node want NPM to work. And so the reason it broke was actually due to the way that GracefulFS works. How many people here have used GracefulFS before or know GracefulFS? How many people have used Gulp before? Okay, cool, so it affected you. So Gulp uses this thing called, they have like a special file system wrapper that underneath it uses GracefulFS. And what GracefulFS does is it takes, there's a hidden API in Node that you can do to get the actual source code for all the modules. And it would go and it would dump out the source code, load it up in a VM module, execute it to create a new version of the FS object, monkey patch that version of the FS object and replace the reference so that every time you used it, you would be using kind of this new version and keep the old reference so that it wasn't overwriting internals, which is great, except when it breaks. And what broke was that we created a new internal API to move parts of the deprecation message part internal in a util. So when it actually tried to execute the code, it was hitting this code that didn't exist. So we came up with a short-term solution, which was to actually just copy and paste all of that internal code directly in line into the FS module. And we fixed it. But how are we supposed to know that like this random little change, like literally moving a deprecation message, would blow up the world? And it turned out that this tool that we use called CITGM, Canary in the Gold Mine, saved the day. So what exactly is CITGM? As I said, the acronym stands for Canary in the Gold Mine. And no, it's not a misspelling. We know the expression is canary in the coal mine. My colleague, James Snell, just thought it sounded good. And it's a form of smoke testing that we use in the Node.js project to make sure that we don't break your code and make sure that the ecosystem is healthy. So what it does is it will grab a module from NPM. It will go grab its source code from GitHub. It will run npm install and run npm test, and then report the results of that run. We run CITGM in our continuous integration environment, so we can take a specific SHA from the Git tree of Node, and then run the test suite of a specific module and report the results. It has a logger with various verbosity settings, so you can use it. This is an example of just the normal output on a module called Oh My God, I Pass. It's a module I wrote. It just exits 0. And this is what it looks like with the most extreme verbose settings, so you could see, everything that's happening over the wire. It also has a markdown output. This you could see running on another module I wrote called Oh My God, I Fail. It exits 1. And here you can see kind of the markdown output that it gives. It can also output TAP, which is really great if you're running in a CI environment, because most CI environments can just consume TAP and then generates a visual layout for you. And it turns out Jenkins TAP plugin is really bad, so I had to write an XUnit reporter as well. It made me sad, but it's okay. But yeah, writing XUnit XML is interesting. So we have this extra tool that's built in called CITGM all. So internally in the CITGM module, we have a lookup table, and in that lookup table, we have 99 of the top modules from the ecosystem covering a whole bunch of different facets. And when we run CITGM all, it runs the test suite of all of those modules and then gives us a report with the results of all of them, so we can see if we're breaking things in the wild. This includes core ecosystem modules such as request, express, body parser, gracefulFS, level, async, WS, socket IO, serial port, Lodash and underscore. And then I think on my screen I could see, oh, that's Q and Bluebird. I like promises, I promise. I didn't do that on purpose. It also includes modules for streams, such as readable stream, through to, split to, duplexer to, BL, binary split, SAX, and duplexify. Now these are modules you may not be necessarily using yourself, but I promise you somewhere in your stack, if you're running Node, a lot of these are being used. Oh, and Pumpify, that's an interesting one if you're using streams, to like tie together a whole bunch of streams together and have a callback only when all of them are complete, and from to. It also includes modules for front-end and tooling, such as Browserify, VinylFS, Gulp, React, jQuery, Node SAS, Ember CLI, Commander, and Pug. It used to be called Jade. I'm bitter about it. But we're really trying hard to make sure that we're testing front-end modules as well. And we catch weird stuff. You'd be really surprised. Natively compiled modules are a huge one. Those are ones that can break if we change the ABI at all. That's the application binary interface. Grab me later if you want to find out more about that. We test serial port, we test level down, we test bcrypt, Node SAS, SQLite, Electron prebuilt, FFI, Node report. If any of these modules break, we know in advance and we can fix it before it gets out into the wild. So why? Why are we doing that? Every test in the Node.js ecosystem is an integration test for core. Every single test in every single module on GitHub is running code that's inside of Node. Even if you have 100% test coverage, which we don't, we're pretty good. I think core is in the high 80s or low 90s at this point. But even if you're covering every single code path, you're not necessarily covering every usage of the code path. And a really great way to do large-scale testing is to test how your clients are actually using your code. By running the ecosystem test against a specific version of Node, we can find out what's going to break before it breaks. And it's, we're like precogs. It's exciting. We run CITGM all in CI for all Semver major changes and releases. If it doesn't pass, the changes don't land, or at least that's the idea. We have a bunch of releases planned for Tuesday. There was a security vulnerability in OpenSSL, very, very low vulnerability for Node, which is why we didn't do an immediate release. We had some releases planned already. And so what we could see really quickly here, I just kind of, by the way, if you can't read it, just scream enhance. It works. But we could see here the build for 6.12.0, and we could see that 12 modules failed. And we can also see that I ran the same test on 6.11.5, which was the last version of 6 that passed. We could see all the platforms that we ran it on, PowerPC, BE, and LE, that's Big Endian and Little Endian, Ubuntu 14.04, Fedora, OS X 10.10, Debian 8, Windows, Visual Studio 2015, AIX, RHAL 72, that's Red Hat Enterprise, Ubuntu 16.04 and 12.04. So it's a very wide range of operating systems, kernels, and runtimes. And so we could see what failed here. And you can just look quickly and we can see, Ava's failing everywhere, which isn't good. ESLint is failing on a couple environments. Yarg's failed on Ubuntu. That's not good. But this is what is failing right now on the previous good release. So we can now look at the new release, and we could go and take a look. We could see Ava's test suite. We could see, all the output. I won't make you look at that. But by quickly comparing these, I can start to see, like these failures on OS X are new compared to the last ones. We had Mocha, ESLint, and Ava fail, but here we have Ava, ESLint, jQuery, and Malter. And so we can go in and look at the output of these and quickly start to see if there's something that we need to be worried about. And so disk storage should process empty fields and an empty file. So that seems like there might be something weird with a file system change that we made. So what I'll be able to do now is go in, audit all the commits that we have on that release, and make sure that one of these isn't causing that failure. I'll also be able to go and, for example, this is Malter. I can go into my terminal, and this is fun. I can do like npx CITGM v verbose Malter. We'll run that in the background on my system while we continue the talk, and we'll come back and check in a second. And we'll be able to find out if that was just a weird CI failure or if we're actually breaking Malter. And if Malter is broken, I can then use like the magic of git bisect to find the actual commit that broke it and make sure it doesn't go out in the release. So how does this work? We do a lot of wrapping. npm view, which is the command that you can use. npm view and a module will give you the package JSON with all the information about the module, the latest version, where the tarball can be located. We wrap that. npm pack in the name of a module will give you back a tarball of that module. We wrap that. npm install. I think you know what that does. We also wrap that. Sorry, I'm just going to stay on this one for a second. npm test, you guys can say it with me this time. This one's a puppy burrito. I think you could also call it like a paparito. So cute. And so you may be asking yourselves, why do you use so many child processes? And maybe I didn't make that explicitly clear. For every single one of these commands to npm, we wrap it in a child process. We monitor std out and std err, and then we bubble that up and keep track of it so that we can actually create a report at the end. And the reason that we do it is because npm already does this stuff. There's no reason for us to program it. And every build that we do in CI already has npm, so it's already there. There's no need for us to do it. Also, the npm CLI API is not going to change on us. npm's internals doesn't have any sort of contract for their API. They're actually doing a really good job now breaking out a bunch of the internals into their own modules, which is really cool. Like Pacoche, we're looking at something that we could replace a lot of this child process stuff with. But by just calling out to npm, we just know this stuff is going to work, and we know that for the most part it shouldn't fall out from under us. And if things break, it's probably our fault. So back to kind of like these fun stories. Dear Diary, today we broke body parser. This wasn't fun. So query string. How many people have used the query string module in Node? So keep your hands up. How many of you have ever used body parser? How many of you have used Express? So you could see that this is a problem. Query string .parse will take a query string from a request, and it will break it up into an array of like what all the elements were in the query string. Under the hood, it's basically just calling string.split. Is nothing too fancy. But this is really, really hot code. This is being run in body parser every time that there's a request, which means it's being run every time in Express every time there's a request, which means that this is being run a lot. So a really, really small optimization to query string.parse can actually have a huge benefit to the entire internet as far as an optimization is concerned. So in the original code, and you can't really see it here, we were creating the array by splitting on the comma, and then if the array was larger than the number of max keys that was given, we would just make the array smaller. This was creating extra objects in the heap. It was not super performant, and it turns out that there's an extra argument that you can give to string.prototype.split, which is max length, which is really great. So the optimization was literally just handing over max keys to split and letting the V8 engine just handle all of this for us. And this optimization is great, up and until the point of which we deal with infinity. Because it turns out by the JavaScript spec that the number that you give for max keys, or for max length, is expected to be an integer. And due to mathy math, when you infer infinity to an integer, it infers to 0, which is mathematically correct, but not necessarily what we're expecting. So while in the past, calling max keys infinity length 1 on parsing this query string would give you a length 1, after this optimization was landed, it would give you 0, which, while being mathematically accurate, is most likely not what you expected to happen. So we didn't have a test for this edge case. But what it turned out was that Body Parser did, because Doug Wilson is extremely on top of things. So when Body Parser broke in CITGM, we were able to see that this edge case existed that we weren't testing for. We were able to literally just change 3 lines of the test, drop the test into core, add 1 if statement, and then we didn't break everyone. Now the odds are that there aren't tons of people passing infinity to max keys, but if there were, this would have been really, really bad, because these are one of those errors that are really hard to even know that is happening. So these are the kind of things that we can catch. I have one last story for you. Dear diary, today we accidentally broke gulp. If you've never seen IT Crowd, it's great. So remember that revert that I talked about before, where we just copy-pasted in the whole thing? Well, a couple months later, we decided to revert that change. So, we took all the code out, and we found failures in CITGM again, because at that time, we had actually patched FS events, and we thought everything was fine. Gulp seemed to be fine, everything was fine. But what it turned out to be was that it actually still broke about 5% of all of the modules on NPM, because they were relying on old versions of that module. So we got the list down by sending pull requests everywhere, but it turned out that explicitly Gulp3 and the entire Gulp3 ecosystem was unable to be fixed, because inside of Gulp, they were using an old version of VinylFS, which in turn was using an old version of GracefulFS. And they didn't want to update the version of GracefulFS inside of VinylFS because they didn't have a broad enough test suite. So we were in this kind of predicament. Should we never update the FS module, and should we stop using our new error reporting methods? Or should we, break a ton of people? And this becomes particularly interesting because Gulp isn't just used by Node developers. Gulp is used by a whole bunch of people who aren't even hardcore into JavaScript. So if all of a sudden, a PHP developer or a Python developer or a WordPress developer is trying to get something to build, and they just download Node from the website, and all of a sudden everything explodes, and it gives this error, which is undefined is not a function. They're not going to know what to do. So we need to have empathy here, and even though core technically wants to move forward, we were kind of stuck. So Gulp ecosystem was terribly affected by this. And to avoid breaking the world, I did a little reggae, which was an autocorrect in an email that I tried to spell regex. So you can now call regular expressions reggaes. But so what we actually did was we went into GracefulFS itself. And we took, you recognize this block of code. We set a regular expression that could check an edge case to know if it was the new versions of Node, and then just inline the code into the VM module while it was, yes. So we didn't end up doing this, by the way. This was just a proposed solution. I call this troll-based development. This is really great. Come up with a really, really terrible solution to a problem, and it will cause other engineers to come up with a better one. But as I said, it wasn't enough. It didn't really work properly. It wasn't scalable, because this was just one edge case that we came into, but any subsequent changes to FS would require this exact same change. And we actually almost gave up. We almost got to the point where we were like, you know what, we're never going to be able to update the FS module, at least not for 2 or 3 years, until this module is out of the ecosystem, because so many people rely on it. Until Isaacs came up with this really, really elegant solution, and we were able to land it. The solution is this thing called natives. Never use it. Natives allows you to do that little hack to grab all of the the actual copy for one of the internal modules, but it'll actually go in and flip an internal flag to also allow for internals, so that internals don't break. And it's just really, really weird, and you basically should never use it unless you know exactly what you're doing, but also even if you do, please don't use it. Don't use it. Here's the API. Don't use that API. But as of Node 7, it wasn't a problem anymore. Node 8, Node 9, we're moving forward, and we're able to keep doing this stuff. What we ended up actually doing was taking that patch that landed on the tip of the tree of GracefulFS and backporting it to all the old version lines so that all of the other versions that were inside of like that version of VinylFS would automatically get updated because it was only a patch update. So, dear diary, even though we broke a lot of stuff, most people didn't notice. And if we go back and take a look at the code here, hey, Multer passed on my system, so I can probably ignore that failure in CI. But that is a reason to celebrate, that things don't break. So, you know, when your code isn't broken, celebrate Canary in the Gold Mine. Gracias. This is Jean-Luc Picard playing a flute.